Okay, here we go to the next part, 3.5, and we're going to look at the derivatives of the remaining four trig functions, all right? So we're going to look at the tangent, cotangent, secant, cosecant. These are the six definitions right here. So the derivative of the sine is the cosine, derivative of cosine's negative sine. We looked at that. Now what we're going to develop is the derivative of the tangent is secant squared x. Derivative of cotangent is negative cosecant squared x. Derivative of secant is secant x tangent x. And finally, last but not least, the derivative of the cosecant x is negative cosecant x cotangent x. Wow, okay. So I'm going to show you a couple of cool ways to memorize that too. I really am. I mean, when you get right down to it, if you memorize this, and this, then the other ones follow logically, and we'll talk about that in a little bit. Okay, so I'm going to go ahead and do a proof of this. The derivative of tangent is secant squared. Okay, well, the key to doing these things is to know your trig identities. So one thing that you would have learned in trigonometry, hopefully, is like the tangent of theta is the sine theta over the cosine theta. So we're going to pull out that identity, and when we do this derivative, let's see what happens then. All right, so I just love doing this. All right, so we got the tangent. I'm going to change that tangent to sine x over cosine x, and we're going to differentiate that then. All right. So that would be a quotient rule. Remember the quotient rule, you go bottom, derivative of top, minus top, times derivative of bottom, all over the bottom squared. Okay, so we're going to pull that out. Let's go ahead and get this put in. So we take the bottom, cosine x, we multiply by the derivative of the top, the sine x, and then minus, we write the top, we multiply by the derivative of the bottom, and one big fraction bar, and that's all over the bottom squared, so we'll write that as cosine squared x like that then. Okay, then we're just going to kind of see what happens on this. So it looks like this is going to be cosine of x comes down. We're going to do two derivatives. We want to do this derivative and that derivative. So we now know that. Derivative of sine is cosine. All right, and then we bring down the sine of x. The derivative of cosine is negative sine x. And then that will be all over cosine squared. Okay, so let's see what we got now. This would be cosine times cosine is cosine to the second x. You got two negatives here, so you got minus minus, so that would be plus sine times sine is sine squared x, all over the cosine squared x. Okay, now we have a trig identity. So the other trig identity that you want to remember something about is the sine squared x plus cosine squared x. What's that equal to? It's equal to 1. That's fundamental identity. So that would be 1 over cosine squared x. Okay, the other thing that you learned is 1 over cosine. What is 1 over cosine? Okay, that is secant x. So you got to know these identities to do all this good stuff here then. So actually this could just be replaced as, and you don't necessarily have to write this step, but it's 1 over cosine squared x, so therefore that is secant squared x, right? So what we did is we just showed, just using trig identities and basic calculus, the quotient rule, that the derivative of the tangent is the secant squared of x. Okay, so we got that one nailed. Okay, so now what I'm going to do is I think I'll do the derivative of the cotangent. I just picked out a couple of these to do. And then generally I like to have students try to do a couple of these too. So I'm going to do one more here and then let you try two on the next page. See if you can get these. Okay, it's important that you can derive these. Okay, so with this one, let's see. The identities we're going to use is the cotangent of x is the cosine over the sine x. Tell you what, since this proof is almost the same, okay, it's very, very similar to the one I just did. Why don't I go ahead and pause the video and just see if you can go ahead and go through and do this one. This would be a good one for you to work with a little bit. So I'll pause, go ahead and try it, see what you get. Okay, so see if you got this worked out. And if you didn't, just take a look at what I did here. I'll just sort of talk through this. So I changed the cotangent to cosine over sine. I did the quotient rule, bottom, derivative of top, minus top, times derivative of bottom over bottom squared. Then I did these two derivatives. Derivative of cosine is, what in the world did I do there? I just see a mistake. That's, that's not right. Okay, there we go. That is a sine x. Okay. Oops. Okay, then the derivative of sine x is the cosine of x. Okay, so I have that. So it looks like I've got a sine times a negative sine as a negative sine squared x minus cosine squared x over sine squared x. Now, you get this negative here. And what you have to do is factor that negative out. So I took out that negative. That left me with sine squared x plus cosine squared x. And then, of course, we know that this identity, that's equal to 1. You still have over the leftover negative. And then from here, really, you don't really have to write that step there. That just gives you negative cosecant squared x like that. So that's the idea, okay? All right, so I'm going to move on to the next page. Pause if you need to. All right, so let's see. I'll do this proof, and then I'll let you do the one that's pretty similar to it, all right? So a couple of ways that we could do this, I guess. This one I'm going to do like this. So we're going to use this identity. We're going to change this to the secant to 1 over cosine x because we know the derivative of the cosine of x. All right, so I'll start the proof like this. We're going to do secant d dx, secant x. We're going to change that to the derivative of 1 over cosine x. And then we'll go ahead and do the quotient rule. All right. So what we do is we do the bottom. We multiply by the derivative of the top, which is 1, minus the top, which is 1, times the derivative of the bottom, or the cosine x. Okay, then we're going to put that all over the bottom squared, or cosine squared x like that. And I'm just going to kind of see what happens, all right? So let's see. We do that derivative, and then we do that derivative right there. All right, so let's see where this leads us then. So that'll be 0, of course. So we're going to get cosine of x times 0. And then over here, you're going to get minus 1. The derivative of the cosine is negative sine x. And then that will all be over cosine squared x. Okay, so that'll go away. That'll leave you, let's see, a negative times a negative. So you'll get a sine x over a cosine squared x. Okay, we're trying to prove this is a secant tangent. Do you see a tangent in here? I do. Okay, so let's write it like this. Let's write this as 1 over cosine x times sine x over cosine x. Okay, so we got that. What is 1 over cosine? 1 over cosine is the secant. So we got the secant. And then what is sine over cosine? That is the tangent of x. Isn't that cool? All right, so that's it. You don't have to do the difference quotient to develop these identities or these derivative rules. Because once you know the derivative of sine and cosine, you can figure out the rest if you have to. And I think it's worth knowing. Okay, so pause the video. I'm going to have you do this and do the same thing. Of course, the key thing on this is the cosecant is 1 over sine x. So you're going to do a pretty similar derivation of that derivative rule. So go ahead and go for it, see what you get. Okay, so if you did that correctly, you're going to know you did it correctly because I've told you what the derivative of the cosecant is. Very similar proof. Use 1 over sine for the cosecant. Put it in the quotient rule. After you do the quotient rule and go through the details there, you will end up with this. Negative cosine x over sine squared x. Just break that up. See, the cosine over sine is a cotangent. And just break it up so that you have 1 over sine and then cosine over sine. Then it works out beautifully. Of course, 1 over sine is cosecant. Cosine over sine is cotangent. Okay, so that's how that goes. All right, so we've established the derivatives now all of the derivative rules on this then. And we're going to go ahead and look at just some basic derivatives of all sorts now. So we'll go ahead and start with this example 1. So what we're doing on this, and you got to know your rules on this. So really the rule that applies to this is the derivative of a secant x is a secant x tangent x. Okay, and then the other derivative rule is d dx of cosecant x. Okay, that is a negative cotangent squared x. Okay, so you can get that from the previous page. I've got all those things written there. Secant, derivative secant is secant tangent. Hold on, did I get that right? No. So I got that wrong. Okay, the cosecant doesn't show up as much. So, but that one is the way that you should remember this is like this. If you're doing a derivative of a cofunction, if your trig function starts with c, it's negative. And then these are cofunctions. Secant and cosecant are cofunctions. So the derivative is a cofunction. So the cofunction of secant is cosecant. The derivative of tangent is cotangent. Okay, so I should have got that right. Okay, so really on this one, then the answer to the problem when you do g prime of x, derivative of secant is a secant x tangent x, and then minus a cosecant x cotangent x like that. Okay, and then that's it. On that, I don't really know if you need to use any trig identities on this. It's kind of important sometimes to try, so I'm just going to try and see what happens on this. I could change the secant to 1 over cosine of x. I could change the tangent of x to sine x over cosine x. And over here, I could change cosecant to 1 over sine, cotangent to cosine x over sine x like this. I'm just kind of curious if I could make this any simpler. I don't really think there's much I can do on this. So I'll probably just leave this alone. I don't think it probably makes that much difference on this, so I think this is an okay answer. Every now and then when you are working with trig functions and their derivatives, something will pop out with an identity that simplifies that a little bit. I don't really see any factoring. I mean, you could change it to sines and cosines, but going beyond that doesn't really necessarily make it any simpler. So I'm going to just leave it alone. Okay, so the next one looks like this is a product rule. So you have two functions that are multiplied. So we're going to apply the product rule on this one. So that's your first function, that's your second function. Okay, and remember, the way I usually do product rule is first times derivative of second plus second times derivative of first. Or some of you might get used to going derivative of first times second plus, let's see, first times second, like that. But our textbook may show it that way. I just learned it this way. I'm just so used to doing it that way. All right, so let's see, it goes like this. So let's go ahead and get this set up in the product rule. So we'll write down the first, and we'll multiply by the derivative of cosecant x. I like to set this up in the product rule before I start doing the derivatives. And then the second is cosecant x, and then we're going to multiply by the derivative of e to the 5x. Okay, like that. All right, so what we have here is then we need to do these two derivatives. Okay, like that. There's a couple of rules for each one. I'll write the rules kind of over at the side here. So we looked at this in the last problem. The derivative of a cosecant of x. Why I remember this is that it begins with c, so I know that derivative's negative. Derivative of a cofunction is always negative. And then it would be cosecant x cotangent x. And then the derivative of e to the 5x goes like this. There's a rule for this, and we haven't learned the chain rule yet. That's in the next section, so that's kind of strange to me that the book waits on that. But this is just itself times the derivative of that exponent. Okay, like that. So there's a general rule that goes like this. E to the kx, its derivative is k e to the kx. That'll make a lot better sense once you learn the chain rule. Okay, so now this goes like this. We're going to have e to the 5x comes down. The derivative of cosecant is negative cosecant x cotangent x. And then we have cosecant x here. And then the derivative of e to the 5x is 5e to the 5x. Now, we do have some simplifying here. We have some factoring we can do. I'm just going to kind of clean this up a little bit. Put my negative in front and write this as negative e to the 5x cosecant x cotangent x plus 5e to the 5x cosecant x. And then I'm going to factor. So you want to develop the habit of factoring. So notice that e to the 5x is a common factor. And we also have a common factor of a cosecant of x. Okay? I like to take a negative out if it's my first term. I mean, there's more than one way you can write the answer to this problem. So I'm just going to take a negative e to the 5x cosecant x out, and then write what I'm left. Okay, so what I'd be left with, see, if once I take that out, is I'd have a cotangent, which would go there. And then this would become minus, okay? And then what I'd have left over here after I take that out would be a 5, all right? So that looks like a good factor to answer that problem. You don't really need to use identities. Can't really think of any reason why you would necessarily need to do that. So I think that's a good answer to the problem then, okay? But if you have factoring that you can do, that's always a good thing to consider when you simplify your derivative. All right, so that is it. All right, okay. All right. Okay, so we're beginning, kind of getting that stage in calculus. We're starting to learn lots of derivative rules. So you want to kind of start working on getting those things down. Okay, so the next thing I'm going to look at is I'm going to do these two right here, these two examples. And this one's a quotient rule. So remember, the quotient rule, it was bottom times derivative of top minus top times derivative of bottom over bottom square. That's something you're required to know in this class. So let's go ahead and get this set up. So the first derivative, we take the bottom, which is the quantity 1 plus tangent x. We multiply by the derivative of the top, which is cotangent of x, minus the top, which is cotangent of x, times the derivative of the bottom. Okay, and then that's all over, one big fraction bar, and then we do the bottom squared. Okay, so square the bottom. All right, so we have that. All right. So now that we're set up in the quotient rule, we need to really ultimately just do these two derivatives and then see what we can simplify. So the rules that you got to apply on this is the derivative of a cotangent of x goes like this. This is how I remember this too, by the way. The derivative of the tangent of x is something you want to really memorize. Secant squared x. Now the way I remember this is, okay, this is a cofunction, so the derivative of a cofunction is a negative. And then the cofunction of a secant is a cosecant. So those are the two derivatives that we're going to need to use in this problem. Okay, so what we have then is we have this. We have, just bring down the 1 plus tangent of x. And then this is going to be the derivative of cotangent is negative. Let's see, let me just write this in a set of parentheses, kind of like this. So this is negative cosecant squared x. Then we have minus cotangent of x. The derivative of this, of course, derivative of 1 is 0. Derivative of tangent is secant squared x. Okay, and let's see, from here, draw your big fraction bar. And then what we'll have is 1 plus tangent of x squared. Okay, so while I'm thinking of this, when you're dealing with the quotient rule, there's really no reason to ever multiply that denominator out. You always want to, when you're working with a quotient rule, try to simplify by factoring the numerator after you simplify it and see if it cancels with something in that denominator. So leave that in a factored form. Now, going through this, there's not really any common factors here. So what I'm going to do is I'm just going to do a distributive property. So I'm just going to take that times that times that, and then just multiply those two things out like that and just kind of see where this leads us. So that would be negative cosecant squared x times tangent of x. And then this is going to be over here just minus cotangent of x times secant squared of x. And then that will be all over the bottom squared, so I'll just leave that as 1 plus tangent x to the second. Now when I get to this point here, I want to play with it a little bit and just see if there's anything I can do to simplify this. Now I'm going to kind of do this over at the side here just to start with. This is something I do on scratch paper. So the numerator I have is this. I have negative cosecant squared x times tangent of x minus cotangent of x, secant squared of x. So I'm going to see where this leads me. This could be written as negative 1 over sine squared x. A tangent of x is a sine x over a cosine x. And over here, a cotangent is a cosine of x over a sine x. And a secant squared is 1 over cosine squared. So I'm just using fundamental identities, and notice what will happen is you'll get negative 1 over sine x cosine x. So it looks kind of like maybe there's a little bit of stuff we can do on this. Then over here, I'm going to get one of those canceling out. So I get 1 over sine x cosine x. Okay? Oh, crap. I just made a mistake, and I didn't see my mistake. Crap, I just saw this. All right, so back here, for whatever reason, I kind of forgot to multiply that by 1. I don't know why I do stuff like that. God, it drives me crazy. I even put the line there showing that I was distributing, but I just wasn't paying attention, I guess. So let me adjust this over here. This would be negative cosecant squared x minus tangent x cosecant squared x minus cotangent x secant squared x. And then this would be 1 plus tangent of x squared like that. All right. So now I'm kind of thinking we'll kind of have to see what I need to do is I just need to add this in over here. So I have negative cosecant squared x like this. Now I could bring that down and just write that as 1 over negative 1 over sine squared x. So now I got a decision to make on this. Do I need to even bother rolling with this any further? Maybe. Okay, I see a couple of ideas here. This thing right here, those are like terms, you see, so you could get minus 2 over sine x cosine x there. And then I'm just going to write this back as a negative cosecant squared x. And then I'm going to write this as negative cosecant squared x minus 2 cosecant x secant x. Okay, so I'm going to do that then. Now, I could factor out a cosecant of x here. So and I'm going to take a negative one out. So if I did, I'd have negative cosecant of x times cosecant of x. What is this thing doing? God, come on. Behave. I don't know why it does this. I have no idea. Okay. All right, so I just need to pause the video and reboot OneNote and see what the heck's going on. Okay, this thing has gone psychotic, but somehow it came back up, so this is kind of where I was. And I was going to take a negative cosecant x out. So if I factor that, okay, this thing's driving me crazy. Okay, so my computer has gone officially psychotic. All this stuff just disappeared that I was doing over here. All right, can't see now it's reappearing. The computer's just messing with me. I think there's a subroutine written in this program to drive the teacher crazy. All right, so here's what I'm going to conclude. I'm going to erase all this stuff. What I was doing on that was just trying to play with the identities and see if it would lead me anywhere that's simpler. I really don't see that necessarily on here, so we are going to leave that alone, and we're just going to say, hey, that's the answer. And that'll happen sometimes with trig functions. You know, you play with the identities and see what happens, okay? All right, so now the next thing I want to show you on this is at this stage in the class you have to work with identities. So remember, we have these Pythagorean identities. You have sine squared x plus cosine squared x equals 1. Another variety of that you have is you have 1 plus cotangent squared x is equal to cosecant squared x. That actually comes from the fundamental identity, and I did that in my head. If I divided everything by sine squared x, you know, identity's equation, then this pops up. See, that's 1. Cosine over sine is cotangent squared. 1 over sine squared is this, okay? So really what happens on this problem then is you can do this like this. So I could go through and move that 1 to this side. If I move that 1 to this side, then what I get is I get cotangent squared x is equal to cosecant squared x minus 1. Now see, that's what that is. And to me, it's just as well on this problem to just change this to cotangent squared x and then do the derivative. Now, you guys don't know the chain rule yet. And so we're at this stage, we have to do this problem this way. So I'm going to have you write out just cotangent x times cotangent x. And then we're going to use the product rule to do the derivative on that then. Okay? So this will go like this then. If I do dy over dx, we're going to go straight to the product rule. So remember, that is first times derivative of second plus the second times the derivative of the first. Okay, so that's how that gets put into your product rule again. First times derivative of second, second times derivative of first, or you can do that backwards of the way I do it, okay? So now I can do this derivative and I can do that derivative, okay? And I've got that derivative rule written right up here, all right? So what we're going to end up having then is cotangent of x. The derivative of the cotangent is negative cosecant squared x. And over here, of course, you get the same thing. Okay, so these are like terms, see. So you would end up having minus, minus. You would have minus 2 cotangent x, cosecant squared x, and then we could go through and put this together. Then let's see what identities give us here. Well, that's an okay answer. That's fine. If we played with identities, the cotangent is cosine x over sine x. Doing this probably won't do us any good. That I can see. I guess there is another thing that we could do. All right, so if you go to this identity right here, okay, the cosecant squared x is equal to 1 plus cotangent. So it's probably worth plugging that in. So you would get negative 2 cotangent x times, and then replace cosecant with 1 plus cotangent squared x. Okay, do you have to do that? Not necessarily. I mean, to me in this problem, that's an okay answer. That's not a wrong answer. That's fine. You just try to work with identities And the purpose of that is really going to be a little more apparent later in the class. And then this would be another way to write the answer, which is fine. Or you could just distribute this out and you'd have -2 times cotangent of x plus cotangent of the third of x. There's all kinds of ways you can write these answers. Okay? So to me, really at this level, you're pretty much okay if you get to that point. Okay? All right, so I'm going to have you pause and do these, and that'll end this part of the video. Then I got to drive fast to get to work. My students are waiting. They have a test today. All right, so good. Okay, so be real interested to see how well we did on this. I went through a lot of trig identities when I worked these out because they did simplify a lot. So I'll kind of show you kind of the key points on these things, and then what I did with the trig identities. So the first one was a quotient rule, and after you put it in the quotient rule and do the derivative, you want to kind of check step by step and see how far you got with this. So once I did the derivative, which is in step 2, then what I noticed is I got all these secants, and then I have a tangent squared. Well, we have this identity right here. Tangent squared t is equal to secant squared t minus 1. The identity is usually written like tangent squared plus 1 equals secant squared, but I can rearrange and do that. So I replace this tangent squared with this. Then I distribute, so I'd have minus secant cubed, and then minus minus is plus secant t. These cross out. You're left with secant squared t plus secant t, where a secant comes out, leaving secant t times secant t plus 1, and one of those things cancels out. See, basically a secant t plus 1 is the same as 1 plus secant t. So one of those cancels out, you end up with that answer. Isn't that cool? See, that's why you got to use trig identities to simplify this. Same thing happened on this one, actually. So you want to check and make sure you did the product rule. First derivative of second plus second derivative of first. Okay, the derivatives go like this. Derivative of tangent is secant squared. Derivative of secant is secant tangent. That's your derivative right there. I just simplified it. That would be secant cubed x plus tangent squared x times secant x. I did the same thing. I did this identity right here. The tangent squared is equal to this. That's just so I get nothing but secants in my answer. So now distribute, that would be secant cubed x minus secant x. Those are like terms, so there's 2 of those. All right. And then I factored that secant out. That's it. Okay. All right. So now I got to get to my office. So that'll wrap up this part of the video. Good luck. Have